Chemical reactions and equations. Types of chemical reactions. Chemical reactions involve the breaking and making of bonds between atoms to produce new substances. As we already know, chemical reaction of atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. But it is basically the breaking and making of bonds between the atoms that are taking place. Types of chemical reactions: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction. Combination reaction: when two or more substances, elements, or compounds combine to form a single product, the reactions are called combination reactions. For example, burning of coal, that is, carbon plus oxygen gives rise to carbon dioxide. That is, according to this example, carbon and oxygen are combined to form carbon dioxide, which is an example for combination reaction. Formation of water from hydrogen and oxygen. Yes. Hydrogen plus oxygen gives rise to water, that is H2O. This is also an example of combination reaction because two substances or two elements, that is hydrogen and oxygen, are combined to form a single product, that is water. Let us consider an example for combination reaction. Calcium oxide reacts vigorously with water to produce calcium hydroxide, releasing a large amount of heat. That is, when calcium oxide is taken in a beaker and water is added to the beaker containing calcium oxide, then when we touch the beaker, the temperature of the beaker will be raised. This is because in this reaction there is large amount of heat that is released. The reaction mixture will be warm because of this experiment, and the reactions in which heat is released along with the formation of products are called exothermic chemical reactions. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Decomposition reaction. As the name suggests, a single reactant breaks down to give simpler products. This is a decomposition reaction. For example, if ferrous sulfate crystals are taken in dry boiling tube, let us do an experiment to know what happens. Pure ferrous sulfate crystals are green in color. When ferrous sulfate crystals are burnt, observe the change in color. That is, ferrous sulfate breaks down into ferric oxide, giving rise to sulfur dioxide and sulfur trioxide as gas. That is, ferrous sulfate, that is our green crystals, when applied with heat gives rise to ferric oxide. As we observed in the experiment, there was the release of gases. Those gases are sulfur dioxide, and sulfur trioxide. Why does this happen? Because ferrous sulfate crystals lose water when heated and the color of the crystals change. It then decomposes to ferric oxide, sulfur dioxide, and sulfur trioxide, where ferric oxide is in solid state, sulfur dioxide and sulfur trioxide are in gaseous state. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Consider another example where calcium carbonate breaks down to form calcium oxide and carbon dioxide on heat. Here, when calcium carbonate is heated, it forms calcium oxide, which is solid, and carbon dioxide is evaporated. The calcium oxide thus formed has a major use in the manufacture of cement. When a decomposition reaction is carried out by heating, we said it is called thermal decomposition. The equation is written as calcium carbonate or limestone when heated gives rise to calcium oxide or quicklime plus carbon dioxide is evaporated as gas. Let us consider another example where when lead nitrate is heated, there is emission of nitrogen dioxide. That is, consider a stand with a burner and a test tube containing lead nitrate. When this lead nitrate is heated, observe there are fumes that are formed which are brown in color, which are nothing but nitrogen dioxide. Therefore, this can be represented in our chemical equation as lead nitrate. Lead is represented as B. Lead nitrate, when heated, gives rise to lead oxide, nitrogen dioxide, and oxygen. This is also a very good example of decomposition reaction. And the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. For example, let us consider iron nail dipped in copper sulfate solution. Consider two test tubes A and B which contains copper sulfate solution, wherein we are dipping our iron nail in test tube B which contains copper sulfate solution, and let us compare the solutions and the nail which is dipped in copper sulfate solution and which is not dipped in copper sulfate solution. Consider the copper sulfate solution after 20 minutes of iron nail dipped in test tube B. There is color change. And then let us compare the nail which was dipped in copper sulfate solution and which was outside. And again we find there is change in color. That is, according to the experiment, reaction is iron when reacts with copper sulfate gives rise to iron sulfate plus copper. Here, iron replaces copper. In this reaction, iron is more reactive element than copper. So, Copper from copper sulfate solution is replaced. This reaction is known as displacement reaction. Few other examples of displacement reactions are when zinc is added to copper sulfate solution, then the copper is replaced by zinc. Therefore, it forms zinc sulfate and copper. Similarly, when lead reacts with copper chloride, it gives rise to lead chloride plus copper. In the above two equations also, zinc and lead are more reactive elements than copper. Therefore, they displace or replace copper from its compounds. Double displacement reaction. Double displacement reaction is a chemical reaction in which one component each of both the reacting molecules is exchanged to form the products. What does this exactly mean? For example, let us consider sodium sulfate and barium chloride. When these two are mixed together, the product that is formed is barium sulfate, which is solid, and sodium chloride, which is aqueous, that is solution of water. That is, what is happening here? Let us perform an experiment to know what exactly happens. When barium chloride and sodium sulfate are mixed together, there is formation of barium sulfate and sodium chloride. That is, in this reaction, we have observed that the substance that is insoluble in water is formed, and this insoluble substance formed is known as precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. What exactly happens in this reaction? That is, the white precipitate of barium sulfate is formed by the reaction of two negative ions of sulfate and two positive ions of barium. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions.